Good morning, everyone. Just wanted to take a minute to talk a little bit about quadrilaterals and parallelograms. So this is going to be a bit of a broad overview just to kind of cover the general pieces of information that you need. You can follow along using the notes, which cover the information that are presented in the slides. All right, so what are our actual goals of the day? We are going to describe what quadrilaterals are, and we're going to talk about the similarities and differences of some of the different types of parallelograms. So we're really going to focus today on parallelograms. So we got to start off by asking ourselves, well, what is a quadrilateral? As you kind of would probably have guessed, quad 4. A quadrilateral is a polygon with 4 sides. So it'll be a closed polygon. It'll have 4 sides. So if I just drew any kind of 4-sided polygon, something like that, I mean, it'll be a quadrilateral. It might not have any particularly interesting properties, but it is a quadrilateral. In particular, when we are looking at quadrilaterals, we tend to classify them based on their number of parallel sides. So from quadrilaterals, we're going to go look into parallelograms, which is where we're going to start today. They will have pairs of parallel lines. Trapezoids will only have 1 pair, or 2 parallel lines. And then kites will have none. And then there's obviously the ones that don't fit into any of these categories. So let's start with a parallelogram. So what do we know about parallelograms? Well, parallelograms, by their definition, are going to have 2 pairs of opposite sides be parallel. Okay, so this side right here is parallel to this side. Okay, and then similarly, if I change colors, these 2 are parallel. All right, so essentially what do we have? We kind of have this situation again. This area in the middle would be your parallelogram. So back when we were talking about parallel lines and transversals, we kind of were making this shape all the time. So we have 2 sets of parallel lines. The diagonals, which will be these 2, AC and BD, they bisect each other. So that means that this part and this part are equal to each other. So this part is half of the whole thing. Right? Opposite sides are congruent. All right, so this side is congruent to this side. This side is congruent to this side. Okay, so the sets of parallel sides are also congruent. And the reason behind a lot of these kind of comes down to the fact that, as you can see, when you draw on the diagonals, you get a bunch of triangles inside. And you can actually show that this triangle and this triangle are congruent. And then you can also show that this triangle and this triangle are congruent. And from there, you're able to determine a lot of this information. Okay, so we have that the opposite sides are congruent. Opposite sides are parallel and congruent. Now it says opposite angles are congruent. Okay, so this angle is congruent to this angle. This angle is congruent to this angle. All right. Again, this kind of comes from the fact that if you draw a diagonal, you'll get 2 congruent triangles, which is actually the next part it says there. So because this part and this part are congruent, and this part and this part are congruent, we can actually say that consecutive angles are supplementary. All right, so you can do it all out. You know that all 4 angles have to add up to 360. So these 2 are the same, these 2 are the same. So that essentially means that this one plus this one has 180, or this one plus this one is 180, or this one plus this one is 180. All right, so to recap, parallelograms, they have opposite sides parallel, right? Parallel, 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 parallel. Opposite sides are congruent, so the sets of parallel sides are congruent. And don't forget, parallel means they never touch. So don't tell me that AD is parallel to AB. Opposite angles are congruent, so these 2 right here, B and D are congruent, and then A and C are congruent. Angles are supplementary, the consecutive angles are supplementary. And then finally, we have that the diagonals bisect each other. Okay, so this part of the diagonal is half of the whole thing, and this part is also equal to that part. Similarly with this one, this part is half of the whole thing, this part is similar to that part, or congruent, I should say. All right, so let's do some practice. So let's find the angle. So you know that these are consecutive angles, right? So these are consecutive, so they have to be supplementary. So they add up to 180. So 170 plus x equals 180. So x equals 10. Simple enough. Let's do another one. All right, same thing. They are consecutive, so they add up to 180. Now, if you add something like this one up here would also be 25, right? Just keep that in mind. So 25 plus x equals 180. X will equal minus 5, that would be 75, 155. Okay. So simple enough, nothing crazy. Now, let's look at lengths involving the diagonals. So it says LP is 6, and I have to find the whole thing. Well, remember, diagonals of a parallelogram bisect each other. So if this is 6, this is 6. So the whole thing, well, it's not looking for the whole thing, it's just looking for the other side. If this part's 6, this part's 6. But if it was looking for the whole thing, ln, that'd be 12. But it's looking for this part, so 6. All right, last one. So it's telling us JL, the whole thing is 28. And we know that this is a diagonal, so this will be this will be congruent to this. So I had to break this into two congruent parts. I'm going to do 28 divided by 2, and that is going to be 14. So that means each of these, JN, which is what we're looking for, and NL are 14. Okay, so our answer is 14. So simple enough, nothing crazy. Now, there are 3 specific types of parallelograms. And they each all have their own properties. So a rectangle is just going to be if I have a parallelogram and I have right angles, all right? So essentially before, when we had our parallelogram, you know, this angle was congruent to this angle and this angle was congruent to this angle. And now because they're all right angles, now they're all congruent, right? And that makes sense because if this one's 90, we already know this one has to be 90. And because these are supplementary, 90 plus something equals 180. Well, the other thing is 90, so they're all 90, all right? So a rectangle itself will just be a parallelogram with 4 right angles. So all the angles will be congruent. Now, in terms of properties, it still has everything related to parallelograms. Those don't leave. They stay here. You get to still use them. The only difference is now we have all angles being congruent as opposed to just opposite angles. And also, the diagonals are congruent, all right? They're still bisected, but they're also now congruent. So this diagonal is equal to this diagonal, and this part is equal to this part, which is equal to this part, which is equal to this part. Okay? So that would make these isosceles triangles. Just keep that in mind. All right. A rhombus. A rhombus is a little bit more interesting because it is now saying what happens if we had all the sides be congruent in a parallelogram. So when all the sides are congruent in a parallelogram, you end up with a rhombus. And a rhombus, it still has all the properties of a parallelogram, okay? Still has all these properties. Everything's still the same. But now, as we said, our 4 sides are congruent. But the diagonals are now also perpendicular, okay? The diagonals are now perpendicular. And they are bisecting these opposite angles. That means this part and this part are the same. This part and this part are the same. Okay? This part and this part are the same. This part and this part are the same. That ends up creating these right triangles on the inside, which can be really helpful for solving for different things, like using the Pythagorean theorem and whatnot. And then finally, our last parallelogram is going to be a square. And a square is deceptively annoying on the fact that it is both a rhombus and a rectangle. So this goes back to the old statement, you know, the square is always a rectangle, but a rectangle is not always a square. It's true. So a rectangle, it gives you the 4 right angles. The rhombus, it gives you the 4 congruent sides, and bam, put them together, you got a square. So the square will have all the properties of a parallelogram, and all the properties of a rectangle, and all the properties of a rhombus. So therefore, it's kind of like the super quadrilateral, if you will. It has everything. So all the properties that you already knew, slap them all together, that's a square. So you can write them all down in the chart that is provided in the notes. All right, so that's everything about our general overview of parallelograms and quadrilaterals. Let me know if you have any questions, and have a great day.